evaluate the following integrals. So we got two similar integrals, natural log of x and x times natural log of x. And if we recall formulas from derivative, there is not a single function whose derivative is natural log of x. What we know, the derivative of natural log of x is, if you find the derivative, that's 1 over x. But there is no function whose derivative is natural log of x. Okay, so we can't answer in one line. Then we've seen when we have a fraction or more complicated terms here, like product, then we would try for u substitution. And that's not the case here. I'm just talking about natural log of x dx. Then if u substitution does not work, the next step we try is integration by parts. Okay, what is that? Integration by parts. In that we will have integral of one function, and let's say dv, u dv. Then by formula, this one will be simply uv minus integral v du. And we'll hope this part will be easier to evaluate, the second part. So if we do that, then if we combine with u dv, that leaves just for this one is like u, and that's for dv. Okay, so let u be natural log of x and dv be dx. So in this formula we need to find du. So derivative of u with respect to x is 1 over x, and I'm going to write dx on the other side. Integrate both sides, so 1 dv equals 1 dx, so that's v equals x. Then this integral, or natural log of x dx, is using this formula, okay, u dv, so uv, so u natural log of x times x, u v minus integral v du 1 over x dx. And here x and x cancel. Then we got natural log of x times x minus integral of 1 dx. Integral of 1 is just x, and we write plus c. So this is our final answer. Okay, we let u be the first and dv, then we get this just to satisfy the formulas. Okay, then we are here. Okay, we can write as some of you might be able to memorize, so in this way. Thus, let me put one last, this is done. Natural log of x times x, maybe let's write x times natural log of x minus x plus c. Okay, now let's do the same thing for the second problem, okay, which is almost same. Here we got x times natural log of x. Okay, for that this one is clearly a product, x times natural log of x. Product means we can try for u substitution. That would be generally inside for u, so u would be x, but derivative of x is 1, that would not take this x. So assuming x equals u would not help. If we take ln x, whole thing is u, okay, u equals ln x, then du would be, the derivative would be 1 over x, but we do not have 1 over x, we have x. So the last option, when u substitution does not work, Now the next option would be then integration by parts. So we're going to use integration by parts for this one as well. So our choice might be different. So let me erase this and make room for this problem. So when we have a product of different type of functions, then how to choose u and dv? This is our integration by parts, u dv. So there is a rule, kind of, you can make it I let. So you want to go in this order of u and dv. So inverse functions, then logarithms, algebraic functions, trig functions, and exponential. So if we look at here, we got this one is algebraic function and logarithmic functions. So logarithmic functions come ahead of algebraic. So our u should be natural log of x, and then x, whatever left over, that should be dv. Okay, so here we're gonna let in this way. For the second, let u be natural log of x. Okay, don't just go for the order it's written. If you start with u equals x and dv equals the rest, then you'll be in big trouble, unless you know the formula, this one. But if you follow this I late, so logarithmic function comes first, and then algebraic function. So dv be the rest means x and dx. If we do that, then we need to find du. That's 1 over x, du over dx. So I'm going to write dx on the other side. Integrate here, so v equals, so antiderivative of x means x raised to 1, so x is square over 2. Okay, now let's use the formula. Now this integral x natural log of x dx, that is u dv. U dv equals uv minus v du. So u v, so u is natural log of x times v. V is x square over 2 minus integral v times du, 1 over x dx. Okay, this part is done. So this is 1/2 x squared natural log of x minus, here x cancel, one copy, that leaves 1/2 x. So 1/2 that we can pull to the front, integral of x dx. Now we can integrate this easily. So 1/2 x squared natural log of x minus 1/2 times integral of x is 1/2 x squared plus c. So 1/2 times 1/2 is 1/4. I mean, that would be final. So that's